Okay, in section 4.1, number 47, they're asking us to find the linearization of this function here at x equals a. So we've got our function f of theta is equal to sine squared of theta, and our a value, which is our center of our linearization, really the point of tangency, is going to be pi over 4. So two things we need to find right here. One of them is we're going to have to find the value of f of a. That's the easier part. So let me do that off to the side right here. So f evaluated at pi over 4 is going to be, let's see, the sine of pi over 4, which of course is a 45, 45, 90 in our first quadrant right there. So that's going to be root 2 over 2, but then all of that gets squared right there. So that's going to get us a 2 on top and a 4 on bottom, which is going to be a 1/2. So right there, we've got our point of tangency, pi over 4, and then 1/2 for the y coordinate. The harder part of this problem is coming up with the slope of our tangent, and so that's going to come from our derivative. So f prime of theta is going to equal, let's remember, guys, that any time you see a trigonometric function squared, it's probably better to think of that of, in this case, sine of theta, and then quantity squared. And how do we take the derivative of anything squared? 2 times the same base, which is sine of theta, drop the power by 1, which in this case is just 1, and then multiply by the derivative within. And the derivative of sine of theta is going to be cosine of theta. It would now be times the derivative of that angle, but the derivative of theta is just 1. So there's your derivative, and we now need to evaluate that derivative at our a value of pi over 4 to get the numerical slope of our tangent line. So that'll be a 2 times, well, sine of theta, we just did that work up here in the top right, is root 2 over 2. And because we're at a 45, 45, 90 triangle right here, cosine is the exact same value right now of root 2 over 2. So what does that do for us, guys? This is actually kind of cool. 2 on the top, 2 on the bottom cancel. Root 2 times root 2 in the numerator makes 2, and that 2 cancels with that 2. And when everything cancels out, we just get a 1 left over. So the slope of our tangent, that's what we just found right there, is positive 1. So with the point of tangency coming from right here and the slope of the tangent coming from here, I think we're ready to come up with our linearization. We're going to go to point slope form, which is going to be y minus your y coordinate right here of 1/2 equals your slope, which is 1, times x minus the x coordinate of the point of tangency. That was your a value of pi over 4. So there's the equation now in point slope form, but with linearization, it's kind of implied we always like it solved for y. So we would normally distribute our slope, but with a 1, I can just kind of ignore that right now. We just need to bring that negative 1/2 over to the right. So you're going to end up with kind of an ugly answer here. Y is equal to, it's going to be an x, and normally these constants can be combined, but because of the pi there, you can't really do that. This is going to be an x minus pi over 4, and then a plus 1/2. And I suppose if you were dying to, you could have turned that 1/2 right there into a 2/4 and put that together into something like this, x plus, and I guess we could have made that a 2 minus pi all over 4, but I don't really think that that form is any better than that form right there, so I'd be good with either one. Last thing, and I would not take off if you guys didn't do this on a quiz or a test, but when we're finding linearizations, we very often like to call the function L of x rather than y right there. So I'd kind of like to put that there. So I guess my answer right here, guys, I think would be this one right over here, but you'd of course get full credit for this answer here as well, because that one is equivalent to the first one right there. It's just a question of whether or not we combine the two fractions in the constant or not. So not a real pretty answer, but either one of those is right for number 47.